I'm the Invasive Species Coordinator for Division of Forestry, Fire, and State Lands. And Marissa asked me to give a rundown on Phragmites control on sovereign lands. I'm going to give you just an introduction on Phragmites and Phragmites on sovereign lands, and some of the best practices we've developed for dealing with it, and then a rundown on what is being done about Phragmites and where, and then some of the results that we're seeing. So first off, what is Phragmites? Phragmites is a tall wetland grass. It can grow up to 12 feet tall, and it forms dense monocultures. Its non-native form of Phragmites is highly invasive. It spreads by every means possible, above ground, below ground, vegetative growth, really well by seed. Its seeds germinate really well. It's a super plant. But it's important to note that there is a native subspecies, and it does still exist. It's kind of hard to find. It looks just like invasive Phragmites, but behaves very differently. It can coexist with other plants without taking over. And because of that, it probably led to insidious takeover, where all the wetland managers, they were used to seeing this plant around because of the native form, and they weren't realizing that it was this non-native form from Europe that was starting to take over the wetlands. I'm sure this group knows what sovereign lands are, but sovereign lands are the beds of the navigable waterways in the state. And so this includes Great Salt Lake, Jordan River, and Utah Lake. All three water bodies have lots of Phragmites. So in 2012, there was a study for Great Salt Lake with some remote sensing. They found there's approximately 23,000 acres of Phragmites on the eastern shoreline of Great Salt Lake. In 2012, Utah Lake had about 8,000 acres, possibly more. The Jordan River has also been inundated. However, we had an early success story with Bear Lake, where they were able to catch Phragmites early, and there's very little Phragmites left on Bear Lake. And so why do we want to control Phragmites, or the invasive form of Phragmites? The top reason is its impact to bird habitat. And because it is highly invasive, it leads to a loss of biodiversity, especially with plant communities. It also significantly disrupts hydrology and sediment transport and water availability. And this is really important on Great Salt Lake. If you look at aerial imagery of the drying lake, you'll see that basically everywhere there's a freshwater inflow to the lake, that fresh water is hitting a wall of Phragmites and not really feeding any other plant communities or any mudflat habitat, or even making it to the lake itself. And then recreation access is a big part of it too. Utah Lake had a nice ring of Phragmites around it that was blocking access to the lake. And specifically recreation wise, the waterfowl hunting and birding communities were the ones that really spoke up about this invasion, and kind of called for action, something to be done about it. And so in other words, Phragmites turns wetlands into cornfields. So these photos illustrate it pretty well. On the left is me in the Willard Spur on Great Salt Lake, and I'm standing in a field of alkali bulrush, which is a native emergent plant that's found on Great Salt Lake. Its seeds provide food for birds, and then the habitat that you can see there, you've got open water, a sparse plant that birds can wade through and make their way through, and it's only about 6 to 12 inches tall. And then on the right is Chad Cranny of Division of Wildlife Resources. He's 6'5", and he's probably not even standing on the ground all the way there. So you can just see how dense and thick and tall it grows. And it can convert an area from like what it looks like on the left to the right in a matter of about 5 years. It's pretty rapid takeover. And so I was hired in 2016 to tackle this. Division of Wildlife Resources had been working on it since maybe about 10 years earlier on Great Salt Lake. But so we started really teaming up and working on a process for dealing with it. And what we found is it's a pretty simple process to remove Phragmites and restore other plant communities, but the details are complicated and the details really matter. And we know that we need both chemical and mechanical treatments to remove Phragmites. So for example, if it is burned, it won't die. So last year, there was a large lightning strike fire of Phragmites on Great Salt Lake in Farmington Bay, the Legacy Fire. And that fire was in September. And by the Phragmites had not been sprayed with herbicide. And so this fire, which had 100-foot flames, super hot fire, burned about 1,000 acres in September. By October, the Phragmites is already about 2 feet tall. So it will rapidly grow back. And this process is thoroughly researched for how to control Phragmites. And so I'm incredibly grateful to Dr. Karin Kettenring's wetland ecology lab at a Utah State University. And she's had students that have studied Phragmites from the invasion, what led to the invasion, then how to control it and manage it. And then now they're really working on ways to revegetate and restore after we remove Phragmites. And me and some of the other managers teamed up with Karin's lab to produce these best management practice guides. And so it's really just like taking all their research and putting it into practical guides on how to control Phragmites and how to restore these wetlands. And these are kind of our guiding documents for how to deal with it. And so with that research, we put together the simplest, most efficient way to remove Phragmites. And what that looks like is aerial spraying at the end of the summer. And the herbicide spray at the end of the summer, the timing is really important. You have to have healthy Phragmites to accept the herbicide. And majority of the biomass of Phragmites is its rhizomes and roots. So it has a ton of energy in the base of the plant. And a well-timed herbicide is key to kill that base, which, like I said, if you have a fire come through, there's just so much energy in the plant, it'll spring back to life from those rhizomes and roots. And so after it's sprayed, you need to wait at least 30 days after it's sprayed, and then it's mowed, trampled, or burned. And I'll give a little more info on those in a bit, but that's just to remove the dead biomass and allow light to penetrate to the surface. And then we repeat that process. And that was a big thing that came out of some of the early control research, that we knew we had to repeat this process for many years in order to fully kill that rhizome mat. And then once it's removed, we monitor, decide whether we need to revegetate based on what plants are coming back or what habitat we're trying to restore. And then in some areas where we're able to control water, we try to restore hydrology to a more natural hydrologic cycle. And so there's different versions of this protocol that we create based on the areas we're working. And so with Utah Lake, the hydrology is a bit more simple, and we also don't have control over the hydrology. So it looks like kind of that previous slide I just talked about. It's just spraying and mowing at the appropriate time, repeating that until we get to 10% cover or less, and we observe that rhizome and root mat is starting to break down. And then once we get to that point, we know we can invest time and money elsewhere on other acres. And that area just becomes a phase 2 area, which is maintenance and monitoring, so spot spraying any Phragmites that comes back, revegetating if we need to. So it's a different story on Great Salt Lake. So here's a map of Farmington Bay, and all the ponds that you see on the right are Farmington Bay WMA, and these ponds all have head gates on them. Those little blue dots are head gates that allow water to flow from the ponds out to the lake. And this is where our partnership with Division of Wildlife Resources really comes into play. So they're controlling all the Phragmites inside the WMA in these impounded areas. And then we can work with them in their water control for timing water for Phragmites treatments that are out on the lake bed on sovereign lands. And so what this map is showing is different hydrologic control blocks that we've created. And those are just based on where we know from experience, we can intentionally dry or wet that area using the head gates of these impoundments. And so that makes our protocol a lot more complicated, but allows for much more targeted restoration. So in that scenario, we're able to intentionally flood an area with lots of water to make the Phragmites really, really healthy, which is kind of counterintuitive. We actually want to grow it, have it really, really healthy. And then we know we can get much more effective herbicide treatments, and we can actually accelerate the process of killing it and removing it. And then on our maintenance and restoration phase, we're able to use that water control to do things like control water levels so that we can use grazing, cattle grazing in the area, and without having negative impacts to water quality, because we can intentionally dry up an area. It gives cows access, and then we can let all the cow manure dry out before we reflood it. And then we can also use the water control to better target things like our seeding efforts. So we can wet an area where we know we're going to come in and reseed. And then another important thing that's kind of still a work in progress is we're trying to figure out how long Phragmites seeds are viable in the seed bank. So the Wetland Ecology Lab at USU is currently doing a seed bank study. And we think if we know how long these seeds last in the seed bank, after we remove Phragmites, we could try to intentionally dry an area for a period that lets all those seeds in the seed bank become much less viable before we put water back on. So if we know, okay, there's about 3 years and then the seed viability really drops off, let's drought stress this area for 3 years before we flood it. And so just really quickly what all these treatments look like. We have aerial spraying with helicopter, and then come on the ground and spot spray with different types of wetland tractors once we have a lot less Phragmites. And again, we spray late in the summer to make sure we kill that rhizome mat. And then our first choice for biomass removal is prescribed fire. It's the cheapest and most effective way to remove Phragmites biomass, and it really exposes the ground to that light penetration that we're looking for to further break down that rhizome mat and then allow new plants to germinate. The problem with this is it's really difficult for us to get approvals for these burns. And so you'd think I work in the same division as fire, and this is a great tool. You'd think we'd be burning it all the time. But unfortunately, we have to get approvals the day of these prescribed fires, and it's hard to gather up the resources, get them on site just to have the burn shut down for the day. And so that's one thing I'm working on, is trying to find areas where we're more likely to get approvals for burning. But as of right now, it's really only on the very north end of the lake. It's a different airshed where we're allowed to burn. So since we can't burn, mostly we go to other mechanical removal methods. The first simplest one is trampling, also sometimes called crushing, smashing, rolling, pick your fun term for it. But basically it's just pulling with some type of equipment that hopefully will not sink. Many pieces of equipment have sunk in the wetlands and turned into just very expensive disasters with cranes trying to pull them out. Pull a giant metal roller, and this metal roller pushes the dead biomass down, and the picture on the right there kind of shows the end result that we're looking for. We want to get that soil exposed again. And so this wet mud is mudflat habitat that a lot of the lakeshore used to have prior to Phragmites, and it also is a good seed bed if we're going to come in and revegetate. So another option is mowing, and ideally flail mowing, which helps really, really mulch up that above ground biomass. But this is a bit more expensive, and it's harder to do in wet areas. And then we can also use grazing. And grazing is a really useful tool in a lot of ways in specific scenarios. And so places where I see grazing fitting in the best are if we have areas that we can't afford to do the whole treatment cycle and aim at restoration, we can bring cattle in to control an area, and they can reduce its seed production. So it can, you know, help prevent like a neighboring area to where we're doing restoration. We can bring cattle in, eat a bunch of Phragmites down, and reduce the seed pressure that's nearby our project. And then also when we're further along, which is kind of what this picture shows, this is in Farmington Bay, outside of the Turpin unit. And we've removed Phragmites in this area, and the area is looking really, really good. We can bring cattle in during the summer to come down, and they kind of hunt down any Phragmites and eat it before it's producing seed and spreading. And they also really help breaking down that rhizome mat. So that for revegetation, we are working with the USU lab on all kinds of stuff now for this revegetation piece. We're trying to develop an optimal seed sowing density. So we know we have to sow seeds at a really high density to compete with Phragmites that's reinvading. But these wetland seeds are really expensive. And so we don't want to seed at a density that's just not feasible because of expense. So we're trying to find where's the sweet spot. The other thing is if you sow at really high density and you have a diverse mix, the plants will sometimes compete with each other and you'll actually get less good results. And so we're also developing optimal seed mix compositions. And some of the things that we're looking at is, you know, if we put fast growing annuals that rapidly germinate, will they move into an area quickly, prevent Phragmites reinvasion? And then some of our hardy habitat forming perennials that take longer to establish, they're harder to get to germinate. Hopefully they are part of a succession that come and move into the area after these annuals have claimed that ground. And so there's ongoing studies working on all of this. Another study is investigating microtopography, where we create small changes in elevation on what is otherwise a very flat surface of the lake bed. And we do that with just a simple farm disc and disking. And we found really promising results with that last year. And so that's now our current practice. So we come in and we pull a disc through an area. And what that does is it creates just some diversity in elevation. So if we have different water levels, there's the right moisture level for the seeds in the area, because some areas will be really wet, some areas will be really dry. It's kind of a way to like bet hedge on moisture levels for reseeding. And then we also stratify the seed, which is a process to break dormancy and have the seed germinate more rapidly. So we try to really nail down our stratification process, which is keeping the seeds moist and cold for sometimes up to 6 months before they go out on the ground. And then we're hoping that we get really rapid germination for seeds that are just ready to germinate right away in this like prime seed bed that we've created. Here's kind of what that looks like. So this is alkali bulrush germinating in a disc area. And you can see on the right how kind of flat the topography is there compared to this little hump. And it illustrates really well, just a slight change in elevation made a big difference in our germination rates. And so we're really excited about this process. And we're going to do about 1,000 pounds of seeding with this process this spring. And so some thoughts we have on some other ideas for restoration. Specifically for Great Salt Lake, we're looking into salt augmentation. So historically, Salt Lake, the Great Salt Lake shoreline would be rising and falling on a fairly regular basis. And when the shoreline comes up really high, it flushes salts into these wetlands. And it's so salty that it'll kill most plants. And so that's what facilitated the invasion of Phragmites in the early 2000s was the floods of the 80s. The water came up so high, it basically denuded all the wetlands of vegetation, and it was a blank slate for Phragmites to take over. And we thought, well, is there a way that we can, because the lake is been low for almost 20 years now and staying low, is there a way that we can actually bring the salt that would be coming in from a high lake level? So we're looking at taking salt from elsewhere on the lake and putting it into these areas and creating mudflat or playa habitat, which is just unvegetated bird habitat. And then another thing we're looking at is, are there ways that we can control the hydrology? Something that is a little bit more like a natural hydrologic cycle, where we have high water levels in the spring and a slow drawdown during the summer. And we know that a lot of native plants prefer that, whereas Phragmites really flourishes when there's perennial flow through the whole summer, which is kind of now the hydrology that we have with a lot of the outfalls and the treatment plants that just send constant flow rate out to the lake all summer long. And then another thing we're working on is remote sensing. Currently we're using drones for this, and we've had success doing this. So we're mapping Phragmites with multispectral drone aerial imagery. This is an example of that outside of Howard Slough WMA. And we're able to very accurately map Phragmites and other plant classes. And we're hoping that we can do this on a much larger scale and have a well-established protocol to do this rapidly. And then as we get further along in these projects, this will really be our method for monitoring and tracking down any Phragmites to go out and spot spray. And so we're doing a lot of work with Phragmites, and there's a lot of people involved with it. On Utah Lake, we have Utah County and then Forestry, Fire, and State Lands. Utah County Weed Control Department really spearheaded the effort before I was hired, and they started in about 2012, and they're still a really good partner. They've got 2 marsh masters on the ground out on Utah Lake that are doing a lot of the mowing and trampling. And then Great Salt Lake, there's a lot of people working on it. Forestry, Fire, and State Lands, and then, as I mentioned, Division of Wildlife has been doing a ton of work in their WMAs. The Nature Conservancy has the big Shorelands Preserve in Farmington Bay. They're doing a bunch of work, and then the Bear River Migratory Bird Refuge is also working on Phragmites. So where is it happening? Where is Phragmites being controlled? For Utah Lake, it's the entire shoreline. So this map shows the cumulative treatments we've done on Utah Lake in partnership with Utah County. It's 10,500 acres. It's the entire shoreline. And then for Great Salt Lake, Forestry, Fire, and State Lands has about 12,000 acres of active control efforts. That's shown in the red. And then that kind of orangey color is planned treatments. And then we have the WMAs, as I mentioned, the Nature Conservancy, Shorelands Preserve, and Bear River Migratory Bird Refuge. Those hash marks are the WMAs from DWR, and so that's another massive amount of acres, and they have been working on that for over probably almost 20 years now, and they have great control of Phragmites in their areas. And so overall, this effort is about 30,000 acres, which, if you remember in the beginning, I said there's 23,000 acres in 2012. There's 23,000 acres of Phragmites in Great Salt Lake. Oh, it's almost all being worked on now. And so what do the results look like? For Utah Lake, we're seeing tremendous success. So the effort really ramped up in 2016. And in 2020, we only had about 3,000 acres of Phragmites left. That's a 70% reduction. This map is showing in red the former extent of Phragmites, so that 10,500 acre estimate. And then the light green is the Phragmites cover that we found in 2020. And you can see in a lot of areas, it's just the higher elevation spots further away from the lake that have a little ring of Phragmites remaining. And those are the areas that are harder to treat because, as I mentioned, you need healthy Phragmites to kill it. And those areas are often a bit too high and dry to get a successful herbicide spray. So what does that look like? From aerial imagery, it's pretty amazing. So the photo on the left, that's all Phragmites out on the lake. And then in 2011, and then in 2020, it's all been removed. that patch of vegetation that's now out on the lake, that's some cottonwood and elm trees. This is on the north shore of Utah Lake. And basically we're just opening up that open water shoreline habitat that a lot of birds use, as well as it's opening up views of the lake and giving people access. And so here's just a photo of what captures kind of what the shoreline looks like now on Utah Lake. This is in Saratoga Springs, looking north, and the light brown color on the far left, that's some remaining Phragmites, but everything else is not Phragmites. We've got a lot of diversity, and this is all passive revegetation. So this happened naturally from the seed bank, which is incredible. So we didn't actually have to spend money to do reseeding. All this stuff just came in on its own. And we're seeing a lot of hardstem bulrush come back in, and that was probably the main emergent plant that was around the shoreline of Utah Lake prior to Phragmites. And so then on Great Salt Lake, we're seeing a lot of success where we're able to follow that kind of more complex treatment protocol that I showed earlier. Basically, we know if we can follow that plan and we're able to control the water as we intend, we can have really good success. We have one area where it only took about 2 years to get to our desired result, which is pretty incredible. However, we are seeing failures in areas where we don't have enough water because we can't get healthy Phragmites to kill it. We've got too much water, which is just facilitating more Phragmites growth faster than we can control it. And then when the water doesn't go where we want it to, which we've had quite a bit, where we open these head gates and we're not sure exactly where the water is going to flow, and it flows into a completely different area than we planned, and it kind of foils our whole treatment protocol. And then another important thing, Great Salt Lake just has so much Phragmites, there's a ton of propagule pressure. So the seed bank on Great Salt Lake is the highest seed bank that's ever been reported in literature for Phragmites in North America. But in the areas where we can follow that protocol, here's what our success looks like. So that gray bar is Phragmites cover. Before the project started, we had 90+% Phragmites, and then after 1 year of treatment in 2018, we're down below 10%. It rebounds in 2019 up to about 20%, which is pretty typical. We do our retreatments, and then in 2020, we're back down below 10%. And you can compare that to our control area where we have no treatments going on, and you can see Phragmites is essentially increasing. And then we compare it to a reference site, which is our desired conditions of almost no Phragmites. And here's what that looks like. So this is that area that I mentioned. It only took us about 2 years to really remove the majority of the Phragmites. But in 2017, Phragmites, as far as the eye can see, some of the densest, tallest Phragmites I've ever seen. In this photo, I'm actually standing on top of a truck on top of the dike. So this is like 12, 15 foot tall Phragmites. And then a few years later, in 2021, there's almost no Phragmites left. You can see a little bit of open water habitat. We have kind of that mud flat habitat that we're looking for, and we see a ton of bird use in this area in the spring and fall. We've got nesting avocets, stilts, and ibis, and all the vegetation in this photo. It's some grasses and then some annual forbs and almost no Phragmites. Here's another area outside of Howard Slough, WMA. On the left is a bunch of standing dead Phragmites that we had sprayed but hadn't been removed yet. And then a few years later, that same area, this is more a kind of playa habitat on the lake. The green plant in there is Salicornia or pickleweed, and that has responded really well. And then the brown is Nuttall's alkali grass, which is a native grass. And so we're seeing success. We're putting all this work in. Where do we go from here? Just continue to follow our protocols that we've made. They're working, and we just have to keep at it. And then as we remove more acres, then we'll be able to invest time and money elsewhere so we can get into new areas and treat additional acres. We can we need to continue to monitor and really establish these best management practices for revegetation that I talked about. And then investigate those long-term restoration approaches that we talked about, kind of manipulating environmental conditions like hydrology or soil chemistry. And then we really need to dial in this remote sensing, because that's going to be a really important tool for our long-term monitoring on such a large scale. And so in the beginning, I mentioned there's also a ton of Phragmites on the Jordan River. So what's being done about that? Well, we're trying to figure that out. It's way more logistically challenging. You think about trying to get equipment access in on the Jordan River. So the equipment we're using to do it on the lakes, we're having helicopters and these giant tractors. You're not going to have a helicopter flying through the center of Salt Lake Valley to spray herbicide. We have steep eroding banks, so we can't use tractors. And then the bank erosion is a problem, because all these banks in the Jordan River are eroding rapidly. If we remove Phragmites, they just disintegrate. And so one of the things that we're trialing, the photo on the right there, is a bunch of willow plantings in an area where we removed Phragmites. And they have these 2x containers that allow light in still, but they provide a protective barrier so we can actually come in and retreat with herbicide for any Phragmites that grows in. And we're hoping that this allows us to simultaneously revegetate while we're removing Phragmites to hopefully reduce that bank erosion problem. And then that photo on the left, so here's kind of what we're dealing with. It's like, we can't get equipment in, so we're gonna have a poor AmeriCorps volunteer in there trying to remove Phragmites. And he's brush cutting Phragmites that we sprayed. And then we have the additional problem of we've got trees mixed in there. And a lot of those are Russian olive and tamarisk, also invasive trees. So there's just a whole lot to figure out, but we're trialing some stuff. And so that's all I have for you guys today. I will just point you to this QR code, takes you to a story map that's on our website that kind of tells the story of the Utah Lake. I also have a poster about Great Salt Lake on there and a fact sheet. And then we're hoping to host treatment databases that will be on the website, and they're interactive, so everyone can see what's going on where.